looking at 12.2 today, chords and arcs. So in a circle, a chord is going to be a segment that hits your circle in two places. So AB is a segment that hits the circle in two places. So that's a chord. And CD is a chord. Now, we also have central angles. Central angles are angles created from the center of the circle. So that's a central angle. That's a central angle. And then arcs, we're familiar with the arcs. We've been working with those. Arcs are a part of the circle. Now, here's the thing. There's all kinds of theorems in this section about these central angles and the arcs and the chords, and ultimately here's the deal, is if one set is equal, if this central angle is the same as this central angle, then this chord is the same as this chord, and this arc is the same as this arc. But instead of them giving me the central angle, maybe they said this arc is the same as this arc. Okay, then I know the others would be the same. So this segment same as this central angle same as this. All right, so I'm not going to get caught up in writing all of those, just to understand that relation. All right, and then here's one other theorem, that if you were to have some sort of a chord drawn in a circle, and you drop a radius perpendicular to it, it will always bisect that, and so, or actually let me take that back. So if you draw these, and then there's these two chords, if this one's the same as this, that's only going to happen if these chords are the same length. Okay, and it does actually hit. When I say it's a perpendicular bisector, it actually will also bisect that chord. Let's practice some. We have in here, it says find the value of x. X is the length of this full chord. But do you see how the distance that it is from the center is the same as this one from the center? And this comes down and it's perpendicular. It's going to bisect it. So if this is 7, then this is 7. So this full chord is 14. But since it's the same distance from the center as this chord, then that chord is 14. So x must be 14. All right, let's look at the next one. Same idea. You have these two chords with a radius drawn to them. They're perpendicular bisectors. Because it's marked with a single hash mark here and a single hash mark here, they are showing us that the whole thing is 15. So these are each 7.5. But do you see that down here they're also 7.5? So if this would also end up being 15, well, if the chords are equal, then they're the same distance from the center. So x must be 8. All right. Let's look at this next one. They're just gonna give us a picture, and we're just gonna try to figure out what x would have to be. Now, in this particular example, I did mention up here that you're gonna create these right triangles, so Pythagorean theorem is always on the table as an option. I know that this entire diameter is 20. So this radius would be 10. Over here, this chord is 16, but if you drop the perpendicular to it, it's going to bisect it. So this piece right here would be 8, and it'd be a right triangle. I think we could do Pythagorean theorem. I'm going to know that this radius is 10 right here, and I'm going to know that half of this chord is going to be an 8, and I'm looking for this other leg. It looks like an x squared plus an 8 squared equals 10 squared. And this is one of the ones that actually comes out nice. When you subtract 64 to the other side, you get 36. So this is a Pythagorean triple, came out nice. So x is 6. Okay, let's look at this next one. It's kind of the same idea, but they didn't make it quite as obvious for us. They didn't draw the right triangle in there. I've got the 8, so I know that this piece here is 4, and this piece over here is 4. And I've got the 3.6. But last time, they actually drew the radius from the center to the edge of the circle. If I do that, draw the radius over here to the end of the chord, now I have myself a nice right triangle. This leg is 4, This leg is 3.6. I could do Pythagorean theorem to find this, but it's just a radius. And the radius, no matter where you draw, it's the same. So if I had it down here, we called it x, well, I'm going to draw it up here. I'm still going to call it x. And I can do Pythagorean theorem to find that. So 3.6 squared plus 4 squared equals x squared. So then on my calculator, I'll have to do the 3.6 squared. And I'm just going to do this all in one shot. 3.6 squared plus 4 squared. And I get a 28.96. And I will square root both sides. So second square root, second answer, okay. And I end up with x equaling 5.4. All right, this is a classic picture where they don't quite draw the radius where you wish they'd draw it. So don't be afraid to draw your radius someplace else. We could have also drawn it over this way. That would have worked also. All right, last slide. This one's for you. See if you can go figure out how long this chord is right here. So using what we've learned in this section, give this one a shot. Pause the video. Come back when you're done. All right, I got a 20.8. I just did a quick Pythagorean theorem on it and used this portion of the triangle, called it A, that's a leg. But they wanted x, which is the full length, so at the end I had to take it times 2 to get to my 20.8. All right, that's all we've got on 12.2. Good luck.